Assalamu alaikum. Today I will explain a regression analysis based on data collected from 200 high school students. The purpose of this regression is to understand how different test scores affect student science scores. The dependent variable in this model is science, and the independent variables are math, female, social studies, and reading. The variable female is a dummy variable where 1 represents female students and 0 represents male students. The regression command used is regress, science, math, female, and social studies, and read. First, I will explain the ANOVA table, which shows how the total variation in science score is divided. The source column shows three types of variation: model, residual, and total. The sum of squares shows how much variation exists. The total sum of square is 19,507, which is divided into model SS and residual SS. This shows that almost half of the total variation in science score is explained by the independent variables, while the remaining half is unexplained. Next are the degree of freedom. Since there are 200 students, the total degree of freedom is 199. There are 4 predictors, so the model degree of freedom is 4. The residual degree of freedom is 195, which is obtained by subtracting 4 from 199. Now the mean square values are calculated by dividing SS by DF. The model mean square is 2385 and the residual mean square is 51. Now I will explain the oral model summary. The number of observations is 200, which means data from 200 students were used. The F value is 46.69. Since the phi value is smaller than 0.05, we conclude that the oral regression model is statistically significant. This means the independent variables together reliably predict science score. The R squared value is 0.4892. This means that 48.92% of the variation in science score is explained by math, female, social studies, and reading. This shows that the model has moderate explanatory power. The adjusted R square value is 0.47. This value is slightly lower than the R squared because it adjusts for the number of predictors and gives a more realistic estimate for the population. Regression equation and coefficient interpretation. The regression equation is science, math, female, social studies, and read. First, the coefficient of math is 0.38. This means that if a student math score increases by 1 point, the science score is expected to increase by 0.39 points, holding other variables constant. The phi value is 0, which means that math is a highly significant predictor of science. Next, the coefficient of female is minus 2.01. This means that female students score about 2 points lower in science than male students on average, holding other variables constant. However, a phi value is 0.051, which is slightly greater than 0.05. Therefore, female is not statistically significant at the 5% level, although it is very close. The coefficient of social studies is 0.05, meaning 1 point increase in social studies leads to 0.05% increase in science score. In conclusion, this regression model is statistically significant and explains about 49% of the variation in science scores. The significant predictors of science are math and reading, while female and social studies are not statistically significant at the 5% level. Confidence intervals, p-values, and coefficient together help us understand the true effect of each variable.